Okay, so this one here, proof by contradiction, to show that root 3 is irrational. Now, irrational means like it's horrible number, right? So if I work that out on my calculator, it would be a horrible decimal that goes on forever and there's no pattern to it. Rational is the opposite, okay? So that's why we're going to assume here that root 3 is actually rational, okay? And rational is opposite because even though it can be a decimal that can go on forever, right? There's always a pattern to it. So if it was a decimal going forever, there'd be a repeating pattern to it. It would be recurring, okay? So it could be 0.33333 and so on, right? 0.66666 and so on, okay? But those type of decimals, because they are recurring, you can actually write them as a fraction, okay? And this is what's true with a rational number, okay? You can always write it as a fraction, okay? Even like 6 is a whole number, or 8 is a whole number. You can write that as a fraction, like 8 over 1, isn't it? 6 over 1, okay? But that's what a rational number is, right? It can be written as a fraction. And written as a fraction, like you got here, a over b, where a and b, right, have no common factors, okay? So obviously, if you can write as a fraction, you'll be able to simplify it as well, right? So, you know, in this case here, we're going to write root 3 as a over b, where there's no common factors. It's simplified perfectly, all right? So what we do then is, we can go with what they've got here. Now, they've got that by, because we've got this here, they've got this by taking the b up here, b root 3 equals a, and then squaring both sides, okay? So you can see then a squared equals b squared 3, okay? So that'll be 3b squared, okay? Now, if you look at what they said then, they said therefore a squared has a factor of 3, okay? Because 3 goes into a squared. That's what it's saying, isn't it? A squared is a factor of 3, and this is written as a squared equals 3 times b squared. So it's a multiple, isn't it? 3 times b squared. So a squared is a multiple of 3. That's why we can say then it's a factor of 3. Now what's true as well, right? And they're telling me this. If a squared is a factor of 3, then a has a factor of 3. Okay? That's what they're saying. A has a factor of 3. So that if a is a factor of 3, you can write a as a equals 3k. So if a is a factor of 3, 3 goes into a, so we can write it like this, can't we? A equals 3k. Okay? Now, if a equals 3k, right, because it's got a factor of 3, what we can do then is we can substitute it back in, right? So this gets a bit clunky, right? But we'll sub this back in now. So if a is 3k, if you think about it, a squared will be 3k all squared, and we can chuck that in there, can't we? Okay? So a squared will be 3k all squared, which is 9k squared, and we chuck it in there. So we get this. And then, because we chucked it in there, a squared, you can see we've got this. Now what I can do now is take the 3 over and divide. So I end up having to take the 3 over and divide, I end up having 3k squared. Now this means now that b squared has a factor of 3. Okay? And b squared is a factor of 3. Well, we can use the same reasoning as they gave us in the first 3 lines. b has a factor of 3. Now how can a have a factor of 3 and b have a factor of 3 if there's no common factors? Okay? So it's impossible, right? It's a contradiction. It's a contradiction since a and b both have factors of 3. Okay? And they should have no common factors, shouldn't they? They should have no common factors. So therefore, the statement is true.